Hi everyone. Welcome to the Python Web Conference 2022 and welcome to this talk of getting started with Airflow for your data workflows. In this talk, I'll be talking about Airflow, some components of the Airflow, and also, I'll discuss one task which I did with the Airflow and what are the challenges faced, what was my thought process, and all those really cool and exciting stuff. So my name is Nisarg Shah. Currently, I'm pursuing Master of Science in Computer Science at Arizona State University, and I'm also working as a software developer at Decision Theater. After this presentation, if you have any doubt, any queries, or if you just want to discuss something, feel free to get connect with me on the following social media links. I'll be happy to help. I'll also love to just have a chat about general tech and all the stuff. I actually like to explore tech, and currently I'm exploring internals of distributed systems and all those exciting stuff. So yeah, feel free to connect with me and ask questions. Right. So in this today's talk, first of all, I'll start with some of the Airflow components, and then we'll see it's working and why those how those components could help. And after that, I'll be discussing the task which I did with the Airflow and its challenges and how did I overcome. So the task was so this task was performed in my previous internship at Fountain 9, and there actually we had the current Docker Swarm network, and then we need to create some more services in that in the architecture of the master worker node. So on the worker node, some more tasks need to be created, and then the logs of those tasks needs to be fetched properly, and then some of the dependencies needs to be set up and all those things. So we'll see the further slides. So in Airflow, there are DAGs. So DAG is kind of a we can say it's a collection of tasks and it's a graph. So actually this is the really core heart of the Airflow, or we can say the core concept. And this is the place where you can define all of your tasks, that what you want to do and what kind of function you want to call it in, and all those stuff. And then you can define your dependencies, that which task should be performed after which, and if you want to run some task in parallel or something like that. So DAGs are the place where you can do all this. Now the task. So task is a small piece which is used in, so which you define in DAGs, and in the task you define the execution of what you want to do, and let's say, and also some of the configurations, if you want to schedule this task for some other time, or if you want to make sure that if this task is failed, then if you want to retry it and all those stuff. So all those things are specified in a task. Now operators. So operators is kind of we can say it's a template using which you can define the task. So in a nutshell, we can say that the operators are used for defining the task. Now there are many operators which are available in Airflow. Python operators, bash operators, email operator, MySQL operator, Postgres operator, and many operators. So let's talk about bash operator. So using bash operator, you can actually execute a bash script in that specific task. Using Python operator, you can execute the Python file. Then using email operator, you can send an email on some specific conditions and all those stuff. So operators are really helpful, and those are used for defining the core logic of the task. Then comes schedulers and executors. So scheduler, Airflow scheduler is the place, or is a kind, so that's a specific piece which actually monitors all of your DAGs. And then when it is a time for a task to run, so the scheduler and executors make sure that those tasks are executed, and also all the dependencies which you have mentioned are executed in a proper way. So kind of, like it spins up a thread or a subprocess, we can say, and then it has a sync of all the tags, tasks, and each and everything. And then, for specifying the code in the Airflow, you need to have a folder of tag, kind of so like a tag directory, and in those directory you need to mention all your code specifically. So like this scheduler and executor actually checks for the new files, then it remove your previously processed files because they'll be already processed, and then if any new task or tag is found, then it will process it. It will fetch the status of those, and then it will store the results. So it actually does all kind of execution and all those things, right? So what's actually good about Airflow? First thing, it has really good UI, which I personally liked. And you can like have a look out at logs of all these services in a proper manner. And also you can define the dependencies between all the like tasks. You can define the task in a parallel way. So it's kind of a really good tool. So like the branching thing for defining the dependencies, the parallelism of the task, and all those stuff. The other interesting thing was like, if you want to have a configuration for a specific task, that like if this task is failed, retry this task, then those parameters are also supported in the Airflow in most of the operators. Then it has the notification service. Now if any specific service failed and you want to get a notification, then that is also done, and it is really helpful. So like in a flow where if your pipeline breaks and you want the error immediately on your email, or like you just want to get notified of that specific error, that can be done easily. And there are many different tools supported in terms of operators, which is like Docker operator and all that stuff. So that really makes Airflow useful and handy, right? And the best thing is like it can also be used for automating a data script. So let's say if you are running a cron job, okay, or like if you're just running a bash script or something, then if you run those jobs in the task of the Airflow, like in a specific deck, then at least you can define the dependencies. You can have some of the configurations on that. And like if the data is used, if the script is used, then this can help you debug really faster. And also by defining a proper structure of the task, by defining the process in the task, could also help you to debug your application faster. So in that way, Airflow is really helpful. So this is the basic architecture of the Airflow, like how it runs and all that stuff. So the scheduler, as I told, that like it handles all the execution of workflows, which is like DAGs, and the task execution and all that stuff, like scheduler and the executor. So they actually pass like they actually pass like what to run to the workers, and like they then get the results and then store it. Then the web server actually gives you a kind of an interface in which you can like get to know about each and every specific things, and also you can inspect your task and can also check the status of your task, of your DAGs, and all those stuff. And the scheduler actually, it is connected with a metadata database, which stores the like all the states of the web server. So all the status of the DAGs, tasks, and all the stuff which is served by the web server. And in the like there is a DAG directory in which all of your code will reside. So scheduler will scan the DAG directory, and like if it finds some new files, and it will consider that as the your DAG or as a task or whatever is defined. So this is like this is known as a DAG. it is like a graph, right? And like these are the individual tasks. So, here you can have a configuration. Now, let's say this run after loop task should only be executed if this run me underscore 0 is, pass, like it is executed successfully, then only this task should be run. So all those kind of execution, the steps and some specific configurations, all that can be defined. And then it will have its own status. So each and every task will have its own status. And then like you can also set now, if any specific task fail, then like the further pipeline should not be executed. And at that moment only the processing should stop. So all those different things. So here's the code, right? Here I have generated two tasks. One is like T1 and T2, and the Python operator is used because I am calling the Python file, or like the Python function specifically. So initially we'll create a DAG, okay, which will have a name, and then it will have its arguments. In that arguments, you can define that if you want to have a notification on a failure, if you want to have a retry, and if like what should be the delay of that, and all those stuff. So all those are mentioned in this default arguments. And then we have two tasks, which is this first task, it just calls a print function, like the function where the Apache Airflow is just passed as a parameter, and it will just print the Apache Airflow. And the second task is calculating the factorial, and phi is passed, and the phi factorial is executed. Now here, the structure of the DAG is declared. So this means that T2 will be executed after the T1. And now if you want to add some specific configurations, that now that T2, like if T1 failed, then it should be retried, and after that T2 should be started, and then like some of the tasks should be run in parallel and all those stuff. Then like you can just define it here. But here it means like first of all T2 first of all T1 will run. After its success state, T2 will start its execution, and then T2 will be completed. So like this is just a basic code where you can declare the tasks like a DAG, and then this kind of branch, or this kind of a structure of your DAG. So here, as you can see that, so here we have two branches. One is this latest only, then task 1, and then task 3 and task 4 should run in parallel. So that is defined in this way, right? And let's say and here this task 3 and task 4 wants to be executed in parallel after task 2, then it is defined this way. There are also set upstream and downstream, but it's just the matter of syntax. But so like this statement and this statement has the exact structure in your DAG. So it's just like if you want to set upstream, then you can also do this. It's just fine, right? So this was just kind of a basic overview of the Airflow, like how to define tasks, DAGs, and the structure of your DAG and what can be done. So for running Airflow, like there are three main things. One thing is you can run your Airflow locally. Second is you can use the existing Docker Compose file, which is available by the Airflow community, which is like a really, really good. And the third option is you can have your customized own Docker file where you can have your DB initialization, like the entry point asset script in which you want to do some stuffs, like some connection with some other ports or servers, and not just have your own custom logic. Then also you can do that. So now let's talk about the specific task, like on which I worked on. So it was that I need to create new services, and then so those services should be tasks. And let's think about like I have one service that I will define it as one task. So that service should be started. The execution in that service should be done. All those logs should be stored. And if there is any error in the execution of that service, then the entire pipeline should stop. And the email notification should email notification should be sent with the error, that like what was the error and in which component. And also there was some of the branching, like some should execute in parallel and some kind of dependencies and all those stuff. And these services should be created on the worker node. And then and actually like all these services were using the data from the database which was on the master node. So like it's like fetching some configurations on the master node. Using those configuration, it does some tasks and then sends and then like stores the results back to the master node. So like that kind of a thing. So this was a task that like those services needs to be set up, and then like a proper log should be like fetch from the Docker Swarm services, and the other dependencies and all those should be defined in a proper way. So my thought process was like I declared like those individual services as individual tasks, and then just prepared the architecture about like what will be dependent on what and which services can run in parallel actually. And then like just for the for the implementation part, I just thought that I can like directly create a service using the Docker service create command, right? So I'll just have a sub process dot call code, and in that I'll just have this command call with the shell equal to true, which means like I can fetch the logs, and then this code can be executed in the Python operator, and then yeah, it will be simple, right? So just this was the thought process for this, but there are some issues in this implementation. Now, like what issues? So the thing was, the task will be marked as success as soon as the Docker service create command execution is completed, which means like as soon as the Docker service create like the configuration, as soon as the service is created, the task will be marked as completed. But what our need was, we want to mark the task as completed when the execution in that service is completed, and once all the logs have been fetched and everything is done properly. But in this implementation, it will be just like as soon as the service is created, okay, the task is done, right? And also, in these things, we will not be able to fetch the logs of the command which is executed inside the service. Like there is one workaround that we could have a while loop and then continuously like check the status of the service and then fetch the logs inside from the currently running service. But the state of the the state of the task was marked as finished as the completed task. So like this was not a proper implementation. So like I digged up into something, and like there were a couple of operators available, and then I saw that yeah, as we are working with the Docker Swarm thing, so there are operators available for Docker also and for Docker Swarm also. Then and using Docker Swarm operator, we can actually like create a service in the Docker Swarm network, and then yeah, it had some of the parameters which could actually do this thing. But the thing was, in this both of the operators, some constraints were not available. And like that constraint support is, if I want to start a service in the worker node, then that constraint was not available. So that support was not there in the Docker operator as well as the Docker Swarm operator. And in our architecture, it was like we need to start the service in the current Docker Swarm network, and that also on the worker node where all the processing will be done by fetching the configuration or the input from the other node. So due to that, these two operators were not helpful in this case. So I thought of something different. I thought that, okay, let's use, core Python Docker SDK. So let's use those APIs. We'll create the services using those APIs. And then I actually had this configuration of follow, std out, and stdrr. So as soon as the service is created by client services create API, it actually gives the log object. And using those log object, the logs can be fetched by having this specific set of configurations of follow, std out, and the stdrr. But in this implementation also, there was one issue. And the issue was that the return type of the log object was the generator object. And actually this configuration kept the connection open to read the log in the near real time. But as the return type from the log object was a generator object, the socket was not getting closed in the generator object once the execution of the command was done, due to which there was an infinite loop in the task, and the task was not getting completed even though the execution in the service is completed and all the logs are fetched and everything is done perfectly. So I tried breaking this loop by checking the status of the service, but actually that didn't work. And if let's say if so why it was not working, that because when I was checking, I was actually checking the status of service just below the logs, but due to the open socket, the logs were not getting fetched, but it was in that while loop only for fetching the logs. Due to that, it was not able to just get out of that while loop and then just check the status of the service. So due to that, this issue was coming. And after that, I thought of just take a deep dive into how Airflow Docker Swarm operator is implementing this. So I just saw that Docker Swarm operator uses the same Docker this Python Docker SDK, but there are two APIs, low level API and the high level API. So they were using the low level API. This is the code snippet of the Docker Swarm GitHub code. And there they are using this create underscore service, which is the low level API of creating a service. And then they just have all these configurations and everything. So I thought that, yeah, okay, there might be an issue of this socket thing in the high level API, but in this low level API, there won't be any issue. And after that, I implemented the low level API, but I just faced the same issue of that socket. So the socket connection was open and I was not able to break the loop. So after that, I saw that how the Docker Swarm operator is supporting this fetching of logs. And in that, I just saw that they just have a while true loop, and in that they are just using the next to fetch the next logs and then have an accept of stop iteration. So it actually uses the stop iteration and some other parameters for breaking the log object once it is done. So I actually tried using the stop iteration, but that stop iteration was not working in this specific scenario. So after that, what I thought of was that let's have threads. Now in the threads, okay, there will be one thread which will be fetching the logs from this service created, and there will be a second thread which will actually check the container status, and then based on the container status. So now let's say if we had the configuration there will be there will be an entry point script, and all that thing will be executed, and once everything is done, the container will stop, And so actually we can check the status of the container, like if the container status like is stopped, and once it is completed, failed, and or else like or else like when we have a specific status, we can actually break the loop. Okay, so I just tried that. Yeah, okay. For log in logs, I'll just print that log, and then so like this is in a single thread, and in that same thread I'll just check the status. But this was not working because uh like because of the open connection of the socket, and due to that, like it was just able to what say so like it was not able to get out of the infinite loop. So what I did was that like I created two threads. In the main thread, I was just printing the logs, and in the sub thread, like in the second thread, like which was created, in that the status of the container was checked, like so like whether that container has the task has been completed, or it's failed, or it's like what's the exact status. But it still didn't work. Why? Because the main thread had the logs. So like uh like I like I was just fetching the logs in the main thread, and now in the main thread, if we are getting the infinite loop, then like it's of no use of getting the second thread fetching the logs. So after that, I shifted the printing of logs code to the thread with a special configuration of daemon equal to true. Now daemon equal to, so when we create a thread with the daemon equal to true configuration, so that thread will be deleted, or like uh, that thread will be closed as soon as the main thread is completed. So in the main thread, I was checking the status after every 5 seconds, and in the newly created thread, I was printing the logs. Now this issue was there of the open socket thing and all those stuff. But now as soon as the main thread execution will be finished, that is as soon as like there will be some status of that service, the created thread will be terminated. So that thread will be deleted, and like that is when the task status will be completed, and then that task will be marked as completed, and after that the other task will be executed. So this is how I actually got the behavior which was required by by using the threads, and implementing the low level API of Python Docker SDK using the Python operators, and with the special configuration of a daemon equal to true. So in this way, like in as soon as the task is started, the service will be created in that task, and then we'll be able to fetch all the logs in the Airflow UI. And then as soon as the service is completed, and as soon as the as soon as the service is completed, the task will be marked as passed or failed based on the result and the logs of the service. And after that, it will move forward as per the configurations. So this is like how this task was achieved, right? So the resources used in this presentation were like mostly taken from the Airflow documentation, the Slack community. Like I had been interacting about this task in the Slack community a lot. And the architecture was also taken from the Airflow documentation website only. And these are the two Airflow code links. This is the link where the code base of the Airflow is mentioned, where the logs are fetched. And this is the link where the service is created in the Docker Swarm operator. So like you can just visit it, and like, yeah, it was, this task was really fun for me, as like I really, got to know about like how Airflow is implementing all the stuffs, and how operators are implemented at really low level, and like how the solutions can be achieved for some specific problems, right? So I hope you enjoyed this talk. Please feel free to ping me or like drop me a message if you have any questions, any doubts, or anything to discuss with. And thank you very much for this talk. And also, yeah, I would be really happy if you give me feedback on this presentation. And yeah, see you. Have a great day. Bye.